when we talk about ozone gassing, for instance, it's really turned into a big thing, both in the wine industry, in the brewing industry, and in the food industry. And say 8-10 years ago, I was saying you could store barrels using ozone gas and we didn't have to use sulfur dioxide. And we're doing that. We have well over 1,000 wineries now in Napa Valley that do that. Some of them have been, Schaefer Vineyards has been doing it for 7-8 years now. And it works really effectively, but it took the state of California to say SO2 is a toxic and hazardous material before you get people to say, well, let's try something else. And because now in California, if you're using SO2, you have to have a pesticide license. There's a lot of restrictions on SO2 usage because it's considered toxic and hazardous. So the shift to ozone gas for barrel sanitation was, early guys like Elias at Schaefer Vineyards said, I don't want my guys using that stuff, so let's see what we can do with ozone, and that's where it started for barrel gassing. But when we start talking about wineries or even breweries, there's really three things you want to look, and food industry, but in wineries and breweries, what we're talking about spoilage organisms. And spoilage organisms are, they're everywhere, so they're floating around in all locations. And in order to control spoilage organisms, what we've done is we've looked at three things: wine contact surfaces, anything the product comes in contact with. Breweries are the same thing. Anything that the product comes in contact with, you want to sanitize. General sanitation would include floors, walls, drains, which are really big, and then atmospheric sanitation, which has now become gassing. And barrel room gassing, bottling line room gassing is really big now. Domaine Chandon, for instance, worldwide gasses all their bottling line rooms every night. And so not only are we doing gassing for barrels, but we're doing room gassing. And barrel room gassing's become really big because you can, essentially, if you can raise the humidity in a barrel room, then you can save a lot of topping losses. There's some studies came out of New Zealand and Australia where they were looking at keeping the temperature constant in a barrel room, but raising the humidity by 5 to 10%. And you're looking at massive amounts of money that's not going into the atmosphere. And you don't have to crush any more grapes, you don't have to have any more tanks, it's just money because it's not being lost. The reason historically we didn't, or wineries didn't keep the humidity higher in a barrel room is obviously what? Mold. If you had mold, then it was a problem. Nobody wanted moldy barrels. But what we found is if you gas on a biweekly or weekly basis, you don't get the mold. So you can raise the humidity up, not get the mold, and save a lot of wine loss. If you gas on a nightly basis and you've got a room that's about 95% humidity, you can swab the walls every day and there's nothing living in there. The look at if you can not only do atmospheric sanitation, but if you can improve the amount of product you have to sell and store barrels in a much more environmentally efficient way, then it's a lot better. So when you start talking about barrel sanitation, really what you'd like to have is a way to sanitize barrels where you don't have an impact on barrel flavors and where you can deodorize the barrel if it does have indeed byproducts from microbes in the barrel. And so if we take a look at that, one of the things I always say, if you've got a Brettanomyces barrel that smells like a horse blanket and you steam the barrel, now you've got a hot horse blanket, which is just what everybody wants to pour their wine back into, is something that smells like a hot horse blanket. But because wine's really good at absorbing what? Flavors. And on the other hand, if you can sanitize the barrel and oxidize those byproducts away so you have a barrel that now smells like a healthy barrel, then you're in a much better situation. And what we found was that steaming hot water has a very detrimental effect on barrel flavors, and it destroys them, and ozone doesn't. Ozone goes everywhere oxygen goes. So when you sanitize a barrel with ozonated water, you're doing two things. One, you get a surface sanitation going on, and the second thing is you get the gases penetrating the pores of the barrel. Now, if you're a microbe and you've got your nose stuck out inside of that barrel someplace and you bump into an ozone molecule, you're lysed, which means essentially your cell's blown apart. That's the way ozone kills, is it ruptures the outer membrane of the microbe. And so ozone gas, when you're doing a sanitation cycle with ozone, you get gas buildup inside the barrel, which lasts for about 30 to 35 minutes. And it goes everywhere oxygen goes at that point. And that essentially is why, ozone's so effective at killing microbes in barrels, because you get a twofold effect going on. You get the gaseous effect and you get the liquid effect. The liquid effect is something we look at in more like discrete surfaces, like tanks. And for instance, we're working with Diageo right now, and it's really fast to do discrete surfaces. We're doing 35,000 gallon tanks, and the sanitation time's 3.5 minutes, which is, with parasitic acid, it takes 15 to 16 minutes to get the same efficacy. Same thing with Anheuser-Busch. We're doing their chip tanks. Last year we did the prototyping for their chip tanks. Currently what they use worldwide is they do a chip tank with 180 degree water for 2 hours. That's their sanitation cycle. Ozone takes 30 minutes with cold water. What the protocol is for barrels, and white barrels and red barrels are different. So is that, say we're filling the barrel, what the cellar guy does, say he's going to do 20 red barrels. He's going to do those barrels and they're all red. All right, the first thing he does, he comes in, he takes one barrel, puts the wand in, and starts timing it until the meter right at the top of the bung starts to display ozone. Okay, let's say that's 20 seconds or 15 seconds or what, it depends on the size of the system. But let's say the average in Napa Valley right now with 36 gram per hour systems is about 12 to 15 seconds on a red barrel. Okay, so he reads it at 15 seconds. He says, all right, I'm going to do all the rest of those barrels for 14 seconds. Because if you're doing it for 14 seconds, nothing's coming out of the barrel, but you time the first barrel. Now, if you were going to do 20 whites, what do? You time the first barrel, and then you do all the rest of them based on that time. Now, as you move from month to month, you do the same thing. You time the first barrel every time you start to gas. And let's say we did 15 seconds on these red barrels this month. Next month, it may be only 12 seconds. What happens is, as you go month to month, the gassing time starts to decrease. And that's why it's important that you monitor that first barrel first. Here's the neat thing about this thing, is that when we started doing this with Schaefer Vineyards, and they've won Napa Wine of the Year 2 years in a row after that, is that Elias never said anything about wine quality. He said, well, I want to do this. I did 20 barrels, and now we're going to shift our whole barrel population over, and I don't want my employees working with SO2, and it's all about, he didn't tell me. And then Ken, pardon? Yeah, and then I had Kenzo Estate, Cliff Ledee, Groff, all these guys are calling me and say, when we're getting better wine out of those barrels because we're not getting the sulfur complexes. I mean, you're basically not getting a lot of the chemical complexes in the wine that you're getting when you have sulfur left in the barrel. And that's to a person. I mean, every winemaker I talk to says I'm getting better wine, and tasting wise. And so now you're reducing a toxic and hazardous material. All right, you're reducing chemical usage. Okay, it's safer for your employees and you're getting a better product. That's pretty hard to beat. But if I can knock my barrel program from 90 days a year back to 45, then the system pays for itself just in labor savings. And because it's a lot of man time. I got 2 guys out there for 45 extra days. You know, if you want to save water and save time, it's a big deal. Now, gassing. Let's talk about room gassing. Everybody said, well, if we do room gassing, everybody's going to be exposed to ozone. But that's not the way we do it. To do that, what you would do would set this system up in the other room, or in that room, doesn't matter. Run 2 tubes in here and turn on some fans so you get, air movement. Ozone's a little bit heavier than oxygen, so you got to make it move up. And usually what they do is put a floor fan in, and so you get a circular motion going on in here. Plug the ozone system in, have it turn on at 7 o'clock at night or 6 when everybody's gone. And say the first night for this room, we would run it for an hour and a half. And then the next morning you come in, and the person that comes in has this little critter with him, and he can measure, background ozone. If it's 0, then the next time you gas, you turn it up to 3 hours. And then you come in the next day and you measure and see if you have any background ozone. You keep going up an hour and a half increments until you definitely pick up ozone the next morning. And then you back off a half an hour. So now, let's say we went to 3.5 hours, we've got background ozone, we drop back to 3 hours. That 3 hours becomes this room's standard protocol. So every time you gas this room, it's 3 hours. And when you come in the next morning, there's nothing in here. It smells good, but there's no background ozone. The first guy comes in the morning, measure it. Now what you're gonna find with gassing, particularly in barrel rooms, where you have a lot of barrels, is that, say we set that at 3 hours and we're gassing for 6 months. At the end of 6 months, you might find ozone after 3 hours. And why is that? Because you've used up the demand in that room at this point. So your gassing time shrunk a little bit. So instead of 3 hours, you'll change the protocol to 2.5 hours, and it usually stays pretty constant from that point on. It depends on how dirty the room was to start out with, whether you have it. If you have a brand new room, brand new barrels, once you set the protocol, it stays pretty close. But if you got an older winery that obviously has some problems anyway, if you set it at 3 hours, you may end up at 2.5 hours. So if we wanted to size a machine to gas this facility, I'd say, what's the biggest room in cubic feet? And divide it by 7,000. And then we can come up with how many grams per hour you've got to have in order to sanitize a room this size. And then the savings of product in barrel rooms, if you can increase the humidity, is big. I mean, it's like 2 gallons or 3 gallons. If you had a temperature in a winery, I have tables for this, but say you're at 18 degrees and you leave centigrade and you leave it at that temperature, but the humidity jumps from 70 to 85%. You up the humidity. Then it's about a 2.5 gallon per year saving per barrel. And they have the numbers. I mean, they're all worked out. But so if you got 500 barrels and you're saving 2.5 gallons of wine per barrel, you figure that out in bottles of wine, it adds up really quick. There's some calculations I did in the paper I just wrote. It was 500 barrels and 500 barrels, and it was increasing the humidity 15%, I think, and the savings was $99,000 a year based on the average cost of wine, which is big. I mean, that's money in the owner's pocket without any additional expense. We do the same thing with bottling lines. When you have a bottling line and say you run 7 parts per million into the bottling line, and then you downstream, when you pick up 0.5 or 1 part per million coming out, the bottling line's done. You don't have to go 7 in, 7 out. You just have to have some coming out the other side, because that tells you the demand's been used up. Now I have some brewers that want to funky beer. That's the big thing now, is funky beer. And funky beer is, I tell them, funky beer is great, but you got to have consistently funky beer. For instance, if you buy a 6-pack of funky beer, And then you come back 6 months later and buy the same beer again, you want it to taste the same way if you like it. You don't want it to be a different funky beer the next time you buy it. So their biggest issue now is we want to add stuff to make beer funky. I mean, that's the craft brewing industry. But what I'm saying is, all right, that's fine, but you have to get baseline sanitation before the next product so that you can add the same guys back and get the same stuff you were getting before. That's a challenge because they're actually adding microbes to make things taste weird or good, depending on what kind of beer you like to drink. So sanitation for them is getting back to baseline. And we win here and we want to come back to here. And it's no different for the wine industry. You want a barrel that doesn't provide you something that was in the last barrel. You want to start, fresh so that you get whatever the fruit and the things you're trying to get out of it. So doing floors is really easy because what you do is you pressure wash the floor and then just rinse it. And it's a very short rinse to get the sanitation you're looking for. And you get the drains at the same time. Now, a lot of guys, when they got open drains, like back here I noticed, they'll pull the drain grates out and then pressure wash that in there and then rinse it with ozonated water. So, that becomes sort of a floor protocol. Other things that guys do are presses. Ozone inside of presses doesn't hurt the bladder. A lot of people do their picking bins, Stag's Leap. They pressure wash their picking bins and then rinse them with ozonated water. Schaefer's been doing barrel storage, empty barrel storage with ozone gas for 7 years. They've never lost a barrel. The neat thing about it is this. When the guy comes back a month later to gas, he can do an olfactory on the barrel. I mean, with SO2 in there, you don't smell anything. You don't see some guy going down and doing that. He's going to get a snoot full of SO2. And as far as operation of these things, it's pretty simple. You got, gas, water off. You have gas or water setting on this valve. And then you have this valve over here if you want to do barrels or other. That's it. It's pretty simple. You don't have any pressure control knobs to work with. It all compensates for that stuff. This particular model turns on at 3 to 3.5 gallons a minute. We have a low flow option that'll turn it on at about 0.5 gallon a minute. And that option is used for like bottle washing, like breweries. What they do in breweries is they'll want to rinse the water right on the bottling line and then they purge it with CO2 and fill. That's what Speakeasy does in San Francisco. And so this thing will sit and run all day long doing bottle washing. And then the same system is hooked into the keg washer. And the keg washer runs at 20 gallons a minute. So about every 10 minutes, it'll jump from 0.7 gallons a minute to 21 gallons a minute for the keg washer cycle, and then back down to 0.7 up. And it just goes up and down all day long. So the same system's not only doing bottles, but doing kegs. So those are basically, that's the operation of it. This is, you've heard how loud it is. This is about as loud as it gets. You don't have that high-pitched stuff. You've heard other systems that drives you nuts, and then this is high frequency gets rid of that because, if you have an oscilloscope, you can actually read, it's a radio wave that you're hearing because this is running at a really high frequency. But it doesn't, because it's in a metal box, there's no EMFs or anything coming off of it. That was part of the CE stuff. They had to hit it with lightning, 10 times in an hour. Wasn't that what they did in Texas? We took it down to Texas. I said, "You're actually going to hit it with lightning?" And they said, "Well, yeah. That's part of it has to stand up to 10,000 volt hits and still keep running." My engineers had some fun with that, but Anyway, so that's about it. The system's air cooled. You know, if you can feel it. It's blowing air through itself all the time, and they'll run in. I mean, down in Napa where it's 115 degrees and is sitting out on the crush pad in the sunshine, it's hot. You know, so they run really well. So in this instance, it's set. We got water running. I'm going to flip it to the water setting. So it's ozonating right now. And the reason I had this here, and I want to, if you take a look at this now, we got it. We've got ozone, but very quickly, you can smell ozone in the water, but there's no bubbles coming out of there. Now, the bubbles are what historically have created, background, because it's just basically ozone gas coming out. And with this, you don't have that. So, you can get down here and with a foot, I can't do it, but you can't smell ozone. I mean, we can stand here and run it for a while. You don't smell it because it's in the water, but it's not coming off. Now, and I run it this way so you can see it. Now, if I take this and shift it to the barrel option, it'll have to run for a minute, but in a few minutes, you're going to see lots of bubbles coming off of there, and immediately you're going to pick up ozone. Now, that gas strip and destruct system, and in fact, there's a lot of vendors of ozone out there that are saying now, well, you don't need a safety system. You know why they say that? They haven't got one. And it costs a lot of money, R&D, to make it work. And so, so I offer my systems with or without the gas stripper. I'll tell you why. Because if I add the gas stripper, I'm always more expensive than they are. If I take the gas stripper away, I'm cheaper than they are. So you got to do it, because they're selling it out there in the marketplace, and some people are looking at price tag only, and so we have to play that game. This comes out at about 10 to 12 psi, and that's because the concentrator, that's what it puts out. See the bubbles coming out now? We weren't getting any of those bubbles before. But if we stand here very long, now you start to get the ozone smell coming because it's coming off the bubbles, not the water. And in fact, there's quite a few bubbles coming through now, see them? Now this, if you come down here and smell that now, you definitely pick up ozone. Anyway, you can see the bubbles coming out. As soon as I do this and put the stripper back in line, look at,
oh wow, that quickly.
Yeah, I mean, it's really quick. And so, we got some big bubbles that are still in the line, but it'll go completely away. And so this is the setting that you want to have it on if you're doing floors or that kind of thing. And if you're doing barrels, then you'd like to, put it on the other setting. And now with this system, it's self-protecting. So if you turn the water off upstream or downstream, it doesn't care. It just says, if I have no water, I'm not running. So I always joke because over the last 20 years, I tried to make them close to idiot-proof, but there's always a new one out there, All right, now for gassing, now we change this and shut this down and go over to the gas setting. And the gas is going to come out of it right here. So there's two gassing lines that are here. And if you've been listening to the breathing right here, this is nitrogen coming off. And because the concentrator is taking and pulling in the air and is stripping the nitrogen off from the oxygen, and this is where the nitrogen's being off-gassed. So you can, hear it right there. But there's quite a bit of since there's 80% nitrogen in the atmosphere, you're producing a lot more nitrogen than you are oxygen off of that. It's not totally pure because it's got, we don't want to use 100% pure oxygen to generate ozone because there's a phenomenon called corona cell impact, and if you don't have some impurities in the oxygen, the corona cell production drops off. And so if you're using pure oxygen, you got to purge nitrogen or helium or any inert gas will do it, but you can't be running pure. So what that means is the nitrogen's not coming off pure either. So the concentrators, the nitrogen's also about 95% with a little bit of oxygen in it. And so, but there's guys use that for blanketing, and it works. But you do have some oxygen. You got to be aware of that. But All right, so if we wanted to gas a room, we're going to use both of these. This one basically plugs in right here, and now your nitrogen's coming out here, and then we would plug the ozone in right here, and essentially, so we're going to have the ozone coming out right here on the wand there, okay? And I'm still in the water setting, so if I go in the gas setting, you notice it turned on immediately as soon as I opened this up, and as soon as I close it, as soon as it repressurizes, it's going to go back, shut off. So if you're gassing barrels and you do one barrel and you drop it down inside of here, now we're gassing a barrel, and I mean, you're getting heavy duty gas coming off of there. And now you want to move to the other barrel, the guy just pops it. When he takes it out of the barrel and moves to the other barrel, you're not getting background because it's on standby right now, it's waiting. And then as soon as you pop it open again, you can gas the next barrel. And so it's set up so that, like the water, when you turn off the gas, it goes to standby and waits. So you don't get background when you're moving from barrel to barrel. Now, when you're doing rooms, essentially what you're going to do is put the machine, say, in that other room there, and run both of these hoses into the room. And the reason for that is we don't want to pump 95% oxygen into a room all night long. I mean, you got something called explosive levels that, you know, I mean, you get a lot of oxygen, and if you got a fuel source, then, okay, so as long as you put the nitrogen back in the same room, then you maintain the same atmospheric balance. So, and then you don't have any of that problem. I mean, you can run this, gas the room with a gas hot water heater in the room. It doesn't make any difference because you still got 80-20. Just part of the 20 is ozone and not oxygen. So that's the reason. Now in a big space, and I've had engineers argue with me about it, is that the amount of oxygen this puts out in a big space probably isn't going to have any impact, and they're probably right. But on a small space where I have guys that are doing freezers and refrigerators, and you know, they're doing food freezers, and yeah, you can build up a pretty good load inside of there overnight. And so what I do is I just recommend you use 2 tubes no matter what size room you're doing, because it doesn't matter, you know. And so that's the protocol. And then, you know, so now you've got both gases being shot back into the room, and then you put it on the timing system to figure out. Now, we can actually install a timer in this for a couple $100, or you can get a lamp timer down at the store for 12. Yeah, you know, I'm sort of from the farming background, go get the lamp timer. But I've had actually guys insist that we put timers on it, you know, and, well, okay, fine. But it's gonna cost, you know, because it's just another thing. You notice on the lights here on these now, you see the light motion when I turn this on. Red light goes out, green light stays on, it's operational, and then you've got amperage across the cells. As soon as you close it off, it shuts down, the light comes back on. So now, I've had several wineries that have the yellow light out here for safety, and then they have a green light there. The green light is so the guy on the forklift on the other side of the barrel room can tell when the ozone's on. You know, you can actually look across there, and when the green light's flashing, that means the ozone system's running. And as soon as the green light stops flashing, then he knows that those barrels are finished. You know, so he's got a visual of the system operating or not operating. So, so that's the gassing option on this. The only other thing we got on here that people ask about is this, and that's a ground fault. That's the same thing you got in your bathroom. So if you drop your hairdryer in the sink, you know, you don't get juiced. And I started putting these on there years ago because if you go and look at the plugins in a lot of places, they don't have ground faults on them. By code in the United States, they're supposed to, but that doesn't mean they do. And that is really for the protection of the operator, not necessarily the system. What happens if it picks up any short whatsoever, it's going to kick the power off. And so if you're standing here in water, that's a good thing if you're standing here holding on to this, okay? Because it's going to kick it. the whole thing we started looking at with ozone is, when I first started this, is we've got to come up with the protocols to use it safely. Just like you have to use SO2 safely, you got to use chlorine gas safely. CO2 has killed a whole lot of people. And there's never been a recorded death from ozone ever. And it's been used in Europe since the late 1800s. And that's a pretty spectacular number, actually, because if you look at CO2 or SO2, every year people die from that stuff. So what ozone's considered is an irritating gas. It's not considered a carcinogen, it's considered an irritant. If somebody comes into the room with a meter, and say they walk in there and they get a few breaths of ozone, and say it's even 20 parts per million, it's a leave. But you're not going to pass out and fall over on the floor. You're just going to be aware that it's there. And you shouldn't be in there for any extended period of time, but it's not going to knock you over. What I advise, if you're going to do room gassing, it's always better if you got a meter. If you don't want to walk in, just hold your hand in the room. The meter's going to read it anyway. The real difference with SO2, by the way, is if you inhale SO2 and it comes in contact with the moisture in your lungs, you get sulfurous acid. It's a secondary acid that kills you. Ozone doesn't give secondary acids. When it comes in contact with water, it doesn't create some sort of secondary background problem. Now, does that mean it can't be irritating to people? Yeah, it is irritating. It's an oxidizer. So at certain levels, people that have asthma are a lot more sensitive to ozone than people who don't. Smokers, they don't even know it's there. These systems now, the gas strip systems in these are really advanced. I spent 20 years doing gas stripping. And what this does is when you run water into it, and when you inject ozone into water, you can't get 100% mass transfer into the water. And so you get bubbles left in the water, and those bubbles have ozone in them. And so what we did was, we can look at one of the older gas strip models, which is back here, and then the newer ones, which are in here. They're different. One of them's called a counterflow gas stripper. This one's actually a cyclone gas stripper, this will better. But it took a lot longer to develop. But what it does is it strips all those extra bubbles out of the water, and then there's a catalytic converter in there that converts those bubbles back to oxygen. So what comes out in the water here is bubble-free ozonated water, which means it's in solution. So as everybody knew, we were running this earlier, you can stand right here with this running, you don't smell any ozone. There's ozone in the water for sure. But that's really important, because that means when you're washing floors and doing that type of stuff, you don't want that background stuff around. And now we've got something on this which is really different. Come over on the side of this machine, and it's got a lever here that says all other applications and then says barrels. When you turn this to barrels, what you do is take that gas stripper offline, which is good. Because when you're doing the inside of a barrel, the gas stripper removes about 15 to 20% of the ozone gas and turns it back to oxygen. When you're doing barrels, you'd like to have that 15 to 20% go in the barrel, because it's just better for sanitation of the inside of the non-discrete surface. And so it speeds up the sanitation process, and nothing comes out of the barrel anyway, it stays in the barrel. So, but when you want to do floors or tanks or that kind of thing, then you just switch it back. So the only issue that you face with ozone essentially is off-gassing. There's no bodily contact restrictions, but background ozone is something that when you're using it in the workplace, that you got to be aware of. And so we focus on that a lot. That's what the gas strip and destruct in this is all about, is trying to control that. So the biggest two things is have protocols developed, number one, and number two, it's not like Texas. In Texas, if a little's good, a lot ought to be better. With ozone, enough is good, and that's it. this model is actually a bug buster. I think it's a 24. It may be a 36. Is it a 24? It's a 24, yeah. This one comes in actually 4 models now. It's a 24, 36, 48, 60, and now we have 72. And so this is sort of the smallest one of this model.
But then we have another line.
Then we have another line smaller than that that comes in 3, 6, 12, and 24.
Right.
So, you know, we got a whole spectrum of different systems that we have.
What's the difference between the 24 in the junior models or the?
Yeah, the little 24 is in a smaller, the difference is this, it's not upgradable. Okay. So once you get a 24 in the Destroyer, that's as big as you can ever get. Okay. If you get a 24 in this model and then you came back 3 years later and said, you know, I really need twice as much ozone, we could go to 48 or 60 without getting a new unit.
Gotcha.
Yeah, it's really
so
easy.
Ones, if you bought a 6 in the Destroyer series, you could keep upgrading.
Yeah, you go from 6 to 12 to 24, right.
Other than that though,
they're pretty much equivalent. The difference is this is stainless, the other ones are powder painted aluminum, and you know, which is, they hold up just as well, it's just that they're lighter.
But you can also, it's an option to go stainless.
Yeah, it's like $500 option, you can get stainless on anything.
Right.
But my distributors out there like the aluminum 24 because hauling it around to do demos, it's a lot lighter.
Sure, you may be buying stainless.
Yeah, you know, this is heavier.
Sure.
So what we got here is this system will do both aqueous and gaseous. I mean, it's a multiple use system. And that's what people like about them because if you look at this, you have a water setting, a gas setting, and then you have water and gas set right here. And this will do ozone or oxygen in the gas setting. So you can do micro-ox. And a lot of guys are doing micro-ox with this because it puts out 96, 95% oxygen. And so if you take a diffuser stone, and you know, a lot of guys do it in barrels and they just diffuse a little oxygen into each barrel instead of racking, and saves pulling barrels out of, you know, for racking purposes. One of the purposes of racking is to do what? Add a little oxygen to the wine.
Right.
Well, if you're not trying to get rid of leaves and you just want to add oxygen, it's pretty easy to just drop a diffuser in there and do 5 seconds of bubbled oxygen in there. And compatibility wise, we really haven't had any compatibility issues in wineries or breweries. The only issue you would have would be on a bottling line where you have black Buna-N, you know, O-rings in there, and they need to be changed out to Viton. Viton rubber now there's a lot of Viton rubber inside of this, but it's about the same price as Buna-N, and it's totally ozone compatible. Anyway, the system, the electronics on the system's got a 3-year warranty, and you don't find 3-year warranties on anything. We're really comfortable with the ozone technology. I think it's the best, well, I know it's the best in the world right now. And we don't OEM it out, so, which means nobody can buy it and put it in something else. I stuck with the idea of the Apple idea of let's hang on to the technology and rather than OEM it out to people, so it's reliable. I would say the average life expectancy of one of our ozone systems is somewhere around 12 to 15 years. And at that point, it's not the ozone equipment that's going bad, it's the compressor, the pump, and all the mechanical parts start to deteriorate. So, okay. Other than that, maintenance-wise on these, there's an annual maintenance, which is 2 check valves, and then there's a 2-year maintenance, which is 2 check valves and solenoid valve. And they're right here, so when the lid comes off, they're readily accessible, and they can be done by anybody that can take one thing out and put another one in, okay? As far as any other maintenance, there really isn't any. They come in 220 and 110, so we do them in both voltage. it comes in a couple of configurations. This one is what I call the off-road vehicle configuration. And you know, a lot of guys like it if they're going to roll it across that kind of stuff out there. But you can also get it with coasters on the front. I like that a lot better because if it's in here, you can, you know, drive it around and turn it in circles, and it's really easy to maneuver. This one you have to tip it back and turn it, and yeah. Good thing. There's two things that you have that you're really concerned about. One of them we already talked about with the meter, and that's for background air. Now these come in two different configurations that we have. This one is a light meter. Basically, you notice it goes up to 0.1 there. When you hit 0.1, this meter will turn red. What that's saying is you're above OSHA at that point. Does that mean you have to run out of the room? No, that just means that you need to look at what you're doing and change it, okay? And so it's really as a safety, you know, this is what guys will carry around with them sometimes, you know, so that, you know, they can measure it. There's also safety badges out there for guys working underground, and they change color if you go above 0.3, so you know that, you know, it's gone up. And so you guy can just look at the tag, and as long as it stays where it's supposed to, you haven't been, you know, exposed to any limits. So that's one way of doing it. There's also a digital meter like this that reads out actual ozone, clear up to 50 ppm. So it'll say 2 parts per million right now. Now, most of the people don't use those for safety. What I use them for is if we're gassing rooms and we're doing stuff and we want to know exactly what level it is. But this is good. This is also good for when you're gassing barrels. Remember I said you drop the gassing wand in and set that right there. And when you see this start to read ozone, that means the barrel's full. All right, so if that takes 15 seconds, then what you do is you do that barrel for 14 seconds, which means you're never getting anything coming out of the barrel, so the guy can move from barrel to barrel, but there's no background. And you only have to do that measurement on each barrel one time, you know, for a set of barrels. Now the test kit is probably the biggest thing I recommend for people, and I'll tell you why. I mean, we have really sophisticated equipment that I could put this gas line through something and I can measure exactly how much ozone it's putting out, and I can say the system's working well. You don't have that. The system's $8,000 or something to be able to do that. But what you can do is, like the food guys, they'll run once a day or twice a day. They'll test the amount of ozone in the water. It's really simple. If they've got a process line, they got a tap right down there, and some guy goes down there and he takes a really quick sample, and it takes about 30 seconds, and he knows what's in the water and he records it. So when the FDA comes in and they have to show their sanitizer, they can show these are our readings over time. And so at breweries or wineries, you don't have to do it that frequently because you're not dealing with listeria and, you know, pathogenic organisms. But it's a good idea once a month to run the system at, you know, set it up so it's running at 10 gallons a minute, take a sample, record it, put it, and it should stay pretty constant from month to month. If it starts to do this, say you're getting 5 ppm, you know, for 2 years, and all at once you read it and you're getting 3.5, then that's when you call us and say, you know, I've got less than what I used to. It could be the media beds, could be a number of things, but at least you know it. You're not running 800 barrels not knowing what's in the water, you know, that's, and so once a month, if you're gonna, I tell people if you're gonna, like St. Michel, if you're gonna run 1,000 barrels today, test it. You know, so that the test kit's really easy for that. Once you get the hang of it, you take a 40 mil sample, you have 2 powder pillows, you drop in there, it turns a blue color. And then you take this and you basically titrate it a drop at a time until the color disappears. And each drop is worth 0.45 parts per million ozone. So it's quick to, I mean, my guys do the test in, you know, less than 30 seconds once they're used to doing it. You know, it's quick. And that lets you know that the system's operating correctly. You know. The protocols, that's another thing. We issue the protocols. I usually, if there's a major change in the protocols, I'll email clients with them. If normal is once a year, we'll email out the new ones with any changes on them, and then just highlight and say there's been a couple of changes here. For about 5 years, the barrel gassing was changing almost every month because a lot of people were doing it different ways until we finally came out with a way that seemed to work. But here's the key to all of this stuff. If you don't want spoilage organisms in your winery, then essentially you need to be doing those 3 things. However you want to do it, it's got to be done because they move and they get in, and once they're in, they're hard to get rid of. It's much easier, like Cap Sandy, to start with brand new winery and never get them than it is to go into Mondavi, who has 200,000 barrels, and try to get rid of them. Because getting rid of them is a real problem at that point, you know, because then you've got, we actually did 200,000 barrels and shifted them to other warehouses to keep them separated from the ones that weren't treated. And that it took 6 months, you know, to get rid of the microbe. Because once they're in, you know, and there's lots of ways that they can migrate within the winery. Tom Rinaldi said that really well one time. He says, when sanitation's easy, sanitation gets done. If sanitation's not so easy, sometimes it gets done, sometimes everybody's in a hurry.